Hello Chem 1. On our first day in Unit 10, we spent a little time learning about what a mole ratio is and how to go from grams of a reactant to grams of a product. Today we'll take a look at problems that can help us calculate how many atoms or molecules we have of a certain product. Let's get started. A lot of times we refer to these as non-mass calculations because instead of going from mass to mass or grams to grams, we're going from moles to mass or moles to atoms. We're just using other units besides mass. And a lot of times because of this, they'll have fewer than 3 steps. So if you remember our graphic organizer here, we've gone from mass to moles of a different substance, and then to mass of a different substance. Today, what we're going to be taking a look at is what happens if you know how many moles you have and then want to go to mass. It's just a shortened 2-step problem. Or we might take a look at if you start with moles and want to go to molecules of a product. So you go from here to here. Just like last time, all these problems can be mapped out on the stoichiometry flowchart so that you know where you're starting and where you're going and what ratios you need to get there. Remember, anytime you go from moles of one substance to moles of another substance, you're going to need to use the mole ratio, which means you're going to get those numbers from the coefficients. Alright, our first question here has 12.8 grams of lithium that are reacted with oxygen gas, which is giving us lithium oxide. I've completed the equation down here at the bottom. So the first thing we're going to do is we're going to write down our given. That is always the first thing we're going to do. So we have grams of lithium. Notice though, it wants to know how many moles of lithium oxide. So if we look back at our chart, we are starting with mass or grams of lithium. And we're going to moles of a different substance. So we have to go to moles of our original substance, then moles of that different substance. So the first thing we're going to do is put grams of lithium down here and moles of lithium at the top, and then moles of lithium down at the bottom to moles of our new substance at the top, which is lithium oxide. Now we need our equalities. 1 mole of lithium is equal to the molar mass of lithium in grams, which is 6.97. And then this is a mole-to-mole conversion between two substances, and we're going to look at the coefficients of our substances. So this is a 2:4 ratio, which you could also write as a 1:2 ratio. We would divide by 6.94 times 2, divide by 4, and we get 0.922 moles of lithium oxide. Notice we have 3 sig figs because that's how many we started with. Here's another problem that shows the decomposition of water. We have 0.45 moles of water. So in this case, we're starting with moles. In this case, it just wants me to know how many moles of oxygen I can produce. So if we go back to our graphic organizer, we're starting in moles and we're coming down here to moles of substance B. This is only a 1-step problem. So we put moles of H2O on the bottom, moles of O2, which is what I'm looking to on the top, and then I use my coefficients to come up with an equality. And you can see that this is going to be half as many as we started with. And our answer would be 0.23 moles of O2 after we round. Here's a double replacement reaction. We've got 16.41 moles of barium nitrate, which is BaNO3, 2. And we need to get 2 grams of precipitate. So first thing we need to do is identify the precipitate, which in this case was barium sulfate. You would do this using your solubility chart. And then moles of barium nitrate go on the bottom. And then moles of the unknown, barium sulfate, go on top. Moles of barium sulfate to grams of barium sulfate. Our mole ratio, if you look, is actually 1:1. Then we need to figure out the molar mass of barium sulfate, which is 233.4 grams for every 1 mole. So we're just going to take our number of moles times the 233.4, which would give us 3,830 grams of barium sulfate product or precipitate. So we've just done 3 problems that show how to go from mass to moles, moles to mass, and hopefully you can still do mass to mass problems. During stoichiometry, a lot of times we don't use Avogadro's number to get to atoms and molecules because it's not a useful term when we're talking about a chemistry lab. We usually want to measure things in grams. That doesn't mean you won't have problems that'll ask you about how many atoms would be produced or how many molecules would be produced. So be able to not only stay on the left side of this chart, but also work to the right side to get to atoms and molecules. Keep up the good work. Make sure you're practicing these problems. We'll see you soon.